Have (12a). They tell you to evaluate the limit of 2x ln 1 plus e to the minus x, okay, as x go to infinity. Now, before we even start doing anything, let's try to evaluate what this whole thing's doing, right? So we see a product here. So let's just dissect the product into two components. The first component we have, or the first factor, is 2x. So the limit of 2x at x approaching infinity, you will have infinity. Is that correct? Okay. So ln, now the second component, ln 1 plus e to the minus x. Now, what happened to e to the minus x as x approaches infinity? It would approach 0, right? Because you can think of this as 1 over e to the x, and x is positive and go to infinity. That means that e to the x will get really large. 1 over something infinity that will approach 0. Okay, so that you will have ln, this will approach ln of 1, right? Okay, so therefore from this form you will have 0 times 0, infinity times 0. Okay, so this form is equivalent of writing 0 over 0. Okay, so there you go. There you have an indeterminate form of this one. So now you can go ahead and apply L'Hospital rule for this. Okay, so what's the L'Hospital rule for this? Okay, we can rewrite it as ln 1 plus e to the minus x over 1 over 2x, right? Okay, you can write something like that, so that it has in the form 0 over 0, so that we will have an indeterminate form. Okay, now we take the L'Hospital rule, and again the L'Hospital rule is just taking the derivative of the numerator and the numerator. Okay, so what's the derivative of this one? It's 1 over 1 plus e to the minus x, okay, times derivative of e to the minus x, because this is a chain rule, so equal to minus 1 times e to the minus x, right, over derivative of 1 over 2x is just 1 over 2 times minus 1 over x squared. Okay, alright, so what do we do next? We see there's a minus 1 and there's a minus 1 here, right? So that cancel. So we can write something like this: ln x approaching 0 infinity e to minus x over 1 plus e to minus x over 1 2x squared. Okay. Right. That will equal to, just do some transformation. Okay. This will equal to e minus x, because we divide over a fraction. It means, what does it mean? Times the reciprocal of it, right? So times 2x squared over 1 plus e minus x. Right? Okay. So what do we do next? We see there's a e to the minus x on the numerator, and there's e to the minus x down in the numerator, right? So we can, how about just multiply top and bottom by e to the x, okay? This equal to x approaching infinity. This times in there, that is 1, right? Times 2x squared. Okay? This times in there, that's ex, right? This times in here, that's 1, right? Okay. So now we have a power function on the top, and an exponential function down the bottom. So what do we say? We say that, well, you know from the graph, right? E to the x grow exponentially, meaning that it's growing really fast as compared to x squared. So you can, from here you can say that the limit equal to 0. You can say that. Or if you're kind of not confident about that, or some maybe self, I wouldn't say that word, but anyways, if you're not confident, then you can take another L'Hospital rule and use limit at x approach infinity. Take another derivative. Okay, so if you take another derivative, that's before x, right? E to the x, and then same thing, right? Take another L'Hospital rule, limit x approach infinity 4 over ex, that approaches 0, and this is your answer. Okay, all right. So let's turn to B. Does everybody get a chance to write that down? All right, let's turn to B. For B, they said evaluate the limit at x approach infinity 1 plus 1 over x to the 3x. Okay, so we talked about it before, right? Before we even do anything, trying to evaluate what the whole thing's doing. Okay, so we have a base and a power. We'll look at what the base is doing. Well, 1 plus 1 over x approaching infinity, that means 1 plus 0, right? So the base is pretty much approaching 1. And what the power is doing? 3x, x approaching infinity, that means that it approaches infinity. So we have an indeterminate form, right? So how do we go about doing this? Well, that's a technique, or we call it a trick. You can call y equal to 1 plus 1 over x, 3x. Okay, and take the ln of both sides, ln y. We talked about it before. Ln of a to the b equal to b ln a, so 3x. Ln of 1 plus 1 over x. Okay. All right. So now we're trying to find the limit of ln e. Okay. Why do we even bother trying to find the limit of ln e? Is because later on, if we know what that limit is, then e to that ln y will just equal to y, and there you go. There you will find your limit as the problem asks you to. Okay, so now we look at what limit ln y equal to. So limit x approaches infinity, right, equal to the limit x approaches infinity 3x ln 1 plus 1 over x. Okay, and we can rewrite it as what? Limit x approaching infinity 3x ln x plus 1 over x. Okay, that is equal to, what is that equal to? Well, we look again, we don't know how is it doing. We dissect it into little components or factors and see what it's doing. Well, you see 3x here, so you know that it's going to infinity, right? And you know x plus 1 over x, and you know it that the limit of x plus 1 over x, that is just 1, right? And ln 1 is just 0. So as ln as 1x, as this whole thing approaches 1, ln of that which just approaches 0. So there you go. You have a indeterminate form, but this in terms of a product, we want it in terms of a fraction. We want it in terms of a ratio. So we try to do something like this, 1 over infinity, right? So with that being said, you can write limit x ln x plus 1 over x over 1 over 3x. Okay. you can write something like this. You can write 3x over 1 over ln x plus 1 or x. Why don't you want to do that? Because it's complicating. Okay, you have an L. Not only do you have, sorry, this thing just reset itself. So not only do you have an ln down in the bottom, you have a ratio inside of it, and then you have to do the chain rule again, which is somewhat complicating. So this one, you have 1 over 3x. You don't have to do any chain rule down in the bottom. So it looks simpler, I would say. Okay, so but it's up to your preference, whatever you feel confident doing. But I would suggest you write it in this form. Okay, so now we have in this form, right, 0 over 0. All right, so now we take the L'Hospital rule of that, the limit of x approaching infinity, derivative of that. But you see here, ln of a ratio is equal to the difference of ln's. With that being said, when you have a general case, ln a over b, that will equal to ln a minus ln b. Alright? So, with this, you can say that equal to ln x plus 1 minus ln x. Alright? Okay? Now we go ahead and take a L'Hospital rule. Derivative of the top, which is what? Which is 1 over x plus 1 minus 1 over x. Derivative of the bottom is 3 times minus 1 over x squared. Okay? That equal to the limit x approaches infinity. Now what do we do? Subtraction, yes, you can do subtraction. You can simplify the top, which is x. You multiply up in here, that's x. Minus x plus 1, so that's minus 1, right? Over x times x plus 1, so x squared plus x. Over 3 minus x squared. Okay? That will equal to the limit x infinity. Okay? You have a minus that cancel, right? So 1 over 3x squared, you divide a fraction, meaning you times the reciprocal of it, which means you times reciprocal of it, which means you will have this on the top and this down the bottom. Alright? Okay, now from pre-calculus, right, you know that when you have a fraction and there's a function on the top and there's a function down the bottom, and they both have the same power. This power is 2 and this power is 2, right? The largest power is 2 on top and bottom, which means that you would have the limit of that is just equal to whatever the coefficient you have in front of it, right? So this, you would have the limit equal to 3. Alright? Let me put in a general case here. When you have limit x approaches infinity and you have some a, right? Let's say a1 x n plus a2 x n minus 1 plus dot 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 plus an x, okay, over b1 x m plus b2 x m minus 1 plus dot 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 b n x. This limit would be equal to a1 over b1 if n equal to m. Okay, so that's what you learned from pre-calculus, that if you have the same power, then the limit would just be equal to whatever the coefficient in front of it. This is the coefficient, right? Right? So coefficient is 3, coefficient is 1, so 3 over 1 is just 3. Right? So now you have it. Now you have the ln of y, limit of ln of y, right? Limit of ln of y equal to 3. Okay? So therefore, y will be equal to the limit, actually limit of y at x approaches infinity would be equal to the limit at x approaches infinity e to the ln y. Okay? And that equal to e to the limit at x approaching infinity ln y, and you know this is equal to 3, therefore the limit will equal to e3. Okay, so that's your final answer. Yes? Yeah.